Right.
We're
Well,
live.
I think we're live. I haven't checked. This will be our first time doing this, but looking forward to it. How are you doing, Bryant?
Doing well. Doing well. I was outside farming all day, which felt good.
Awesome. Do you want to give a short little thing on that while I get this set up here? Because I'm going to set it up on Instagram as well here.
Yeah, sure. Yeah, what was I doing? I was spreading a cover crop in the rows of my trees in my orchard. I went with rye, like a cereal rye, and red clover, um, and a very small quantity of just grasses, grass mix. Anyway, red clover is my favorite cover crop. Rye is like kind of a surefire cover crop in most environments. It's very fast to germinate. That's kind of why I went with it, trying to suppress weeds. So it's the only day I've farmed this whole month. I had to get one
Really?
day in before the end of the month.
It's so nasty out here in Washington. I can't imagine doing anything outside.
Yeah, I mean, I just got a few days of like 65, so I thought, well, I'll get out there.
Nice, nice. Well, I know you and I talked about doing connecting on these and doing short videos or short lives here, potentially weekly, which I think would be awesome. And the first thing I want to mention, just for housekeeping, is that we're going to publish these on YouTube exclusively. Bryant's setting up a YouTube channel, so we'll put that in a link on my channel as well as other places so you guys can find it. But we're going to try and move people over to YouTube for longer form content, better dialogue, interaction, that sort of thing.
Yeah, and I just want to add, YouTube feels better in the sense of being able to go deeper into topics, long form, detailed. Um, Instagram's great for quick messages or just short entertainment, but in terms of really diving deep for serious growers, I think YouTube is far preferable. So I'm going to be producing more content over there, and I know you said something similar, Tad.
Yeah, I'm trying to move most of my stuff over there too for that reason because it just seems to be a better format to have a deeper discussion on things. And yeah, so just to kick it off for today, I know the topic we decided on was pH. And by the way, if folks are tuning in, feel free to suggest other topics here down the road for us. Absolutely open to that. But yeah, today we want to talk about pH in living soils or organic systems. Brian, you want to kick it off, or do you want me to throw out some questions that people have had about pH in living soils as a way to spark it off?
Um, okay, so this may be a slight tangent, but I feel like we should just give a very rough definition of living soil because in this conversation of pH in these medias, I think that actually really matters. So how I think of living soil is a um, it tends to be a peat-based media, but it could be a media with a certain quantity of topsoil. It could have cocoa, but usually with a large portion of compost that people are managing with an eye toward biology and implementing practices that sort of stimulate biology. But there's almost always a compost component in there. Sometimes there's biochar or just other organic inputs. Usually it's managed organically, maybe not exclusively, but a lot of carbon is going into that system right out of the gate, but also through multiple rounds. Does that seem like a good baseline to work off of when it comes to living soil?
Yeah, I think we can agree that it's technically a soilless media because it doesn't have that sand, silt, clay component to it of true soil. If we're going to go by this definition, and I know some people, I made a post about a definition of living soil recently, and people got kind of caught up in the weeds, like, well, if you don't have a cover crop on that, is it truly alive? Or if you're not using KNF or soil food web practices, are you really doing a living soil? Or can you have a living soil straight out of a commercial soil bag? And those are all legitimate questions, but I think we need to just agree on a definition just to have the conversation, which
Yeah, exactly. Because a topsoil that's managed sort of regeneratively and biologically outside, that's very living. The pH dynamics are different. Like to explain pH in my topsoil versus my living soil in my grow room is a different conversation. So the reason I say that is because pH in a living soil tends to be a factor of all the individual ingredients. So some of those ingredients are pushing the pH up and some of them are pushing the pH down. And they do that to a different extent over time. And that's where the pH is ultimately going to land. And we can kind of go through some of those interactions or some of those products, I guess, that would be pushing pH up versus pH down and why that matters and where the end pH may result with differing products being used. We can start there, or we could jump into the questions that people have. It's kind of up to you, Tad.
Well, I don't see anything yet on YouTube, but assuming that this stream is working, but I'm seeing some stuff on Instagram. What I can see the Instagram side, and it's way delayed compared to our actual stream. So why don't we just kick it off by talking a little bit about what we're calling living soil. So let's just assume a potting soil indoor environment with how we impact pH there, I guess. And like you said, there's a variety of amendments we can use. Why don't you start off and then I'll go from there.
Yeah, cool. So assuming peat is the primary percentage of a media, peat, as most people know, is slightly acidic or very acidic, and is as it slowly mineralizes, as it slowly decomposes, it just constantly puts downward pressure on the pH. That's one of the only things that's putting downward pressure on a media pH. Most other things are putting upward pressure on the pH. So if you think about the common amendments, obviously lime and wollastonite and dolomite are all specifically for sort of increasing pH, but a crab meal, soft rock phosphate, let's see, anything that contains carbonates whatsoever. Even compost is very rarely acidic. And so even compost is putting upward pressure on the pH, and sometimes super significantly. So generally what I see is once you combine peat, aggregate, compost, and all the amendments to get the nutrient levels up, the pH tends to be at a pretty good place. Sometimes a little bit of lime is needed, but usually not. I mean, in my experience mixing, you have more experience than me. So I think this is where there's a little bit of a narrative that pH doesn't matter in living soil, because right out of the gate, people don't generally have pH issues. Mm-hmm. But that's not, we've talked about this on your podcast. That doesn't necessarily mean that pH doesn't matter or that people don't need to think about it, because there's two things that I see. One is over time, you can see significant drops in pH and plant health issues as a result of that. So that's a big thing. And the other thing is just the influence of water. So over time, if you are using an acidic water, maybe like a well in North Carolina or something, that'll put downward pressure on the pH like peat would. And over time, you're going to see a steep decline in pH once all of that sort of buffering capacity has been neutralized. More common would be a really high pH, high alkalinity water that would put upward pressure on that soil, where the pH would climb and climb and climb into the upper 7s or 8s even. And while you're not going to see as steep of a decline, or I never have at high pHs, it's not optimal. Like you don't want your pH at 8 in a living soil. That would create a number of nutrient uptake issues. So anyway, that's kind of how I think about it. Do you have any thoughts?
I have a ton of thoughts, but going back to this original idea you mentioned when you're formulating soils, I think starting there with peat moss, like you said, with peat moss being so acidic, we're adding a lot of fertilizer, compost, things that are more alkaline. So we're always starting with peat is very nice because we're starting from a very low pH range. If we started with coco coir, which is a more neutral, closer to 7, it's much harder to add the same levels of fertility without ending up in a situation where you have a very, very high pH. So that's one of the advantages of peat moss and why it works so well compared to some of these other substrates even that I see coming onto the market that people are trying to make living soils out of. And that's probably another conversation that I think is really interesting because this is something I've been looking into.
Yeah, me too. We should actually chat. I think we should chat about that.
Yeah. Yeah. But in terms of all of these amendments that we're adding, they do have an impact on pH. With the exception of, gypsum. Someone had mentioned, what do I use to add calcium without raising my pH? And that's really where gypsum comes in. And gypsum's probably its own live all by itself. But I think you really hit on it when you said that optimizing pH, getting it into a range. And keep in mind, guys, this is a range. So it's not like it has to be at 6.6 or 6.8 or whatever your target is. But if you're within 6.6 to 6.8, if you're, for me, and I'd be curious to hear your thoughts, I would like to be 6.6 to 7.1 if I want to create a large range there. And I'm not going to be too worried in that range. So for me, I target around 6.8. But if I see 6.9, even though pH is logarithmic, I think that that's great. So I don't know, what is your range there for pH?
Yeah, so the Soil Doctor tool targets 6.8, and I would agree with you. I think that like 6.5 to 7, something in there is great. But I see great plant health way above 7. So I think what matters way, way more is nutrient sufficiency and balance. 6.5 versus 7.5, I don't think it matters as long as you have good sufficiency and balance. Someone mentioned in the comments mushroom compost. And I wanted to add one more thing about pH that most people don't know, which is that you can drive pH up to an asymptotic limit of about 8.2 with calcium, with lime, essentially. Either high calcium lime or dolomitic lime. We don't recommend dolomitic lime generally, but either of us. But you can, the issue with mushroom compost and where you can really have high pH issues is with sodium and potassium. So with excesses of specifically sodium, but potassium can do this too. You can get your pH above 8.2, and that's where you get a significant drop off in nutrient availability, but you're also fighting a major excess of either sodium or potassium. So whenever I see pH above 8.2, I do get pretty concerned about what kind of excess is happening. The other very niche example that we talked about earlier, Tad, is ammonium can drive pH up.
I wanted to touch on that actually, because I think this is an interesting point for folks. So something that we're dealing with right now with formulating soils is our warehouse at our farm where Andrew is mixing these up. We're not heating the warehouse. It's too large. And so it's cold. And so when he mixes up a blend to formulate, to trial it out, that nitrogen is in the form of ammonium, and it's actually raising the pH of the soil. And that has to cycle into nitrite and then into nitrate, which is the primary form that cannabis wants. And so that process is driven primarily by temperature. It's a microbial process that's driven by temperature. And feel free to correct me on anything I say, Bryant, if I misspeak. But because of that, we recently got a soil test back that we had sent in on a formulation we were trying out, and the pH on it was over 8, and the ammonium was quite high, and the nitrates were low. And this is because the soil was not cycling as rapidly as we wanted it to. But over time, what I would expect as that soil warms up, that I would expect the pH to drop as that ammonium cycles to nitrate, and then my nitrates to go up and my ammonium to drop. So it's an interesting thing, and you can have a lot more of an impact on pH in potting soils or living soils, I think, than you would trying to move an agricultural soil.
Yeah, definitely. Yeah, I mean, the first thing, if I saw anything above 8.2, I would go to the standard soil test and I would look at sodium, and then I would look at potassium, and then magnesium. And then if none of that explained the excess, it would either be calcium or ammonium. Ammonia. Sorry, ammonium. Ammonium is the water soluble form of that cation, and it's a base cation. So yeah, you nailed it.
Well, let's answer some of these questions. I think Margaret has a good one here on YouTube. She asked, "It seems to me pH in living soils is set for minimizing heavy metals, and how many microbes are in the soil?"
So yeah. No, generally pH, the primary reason that pH influences plants is because it makes nutrients more or less available um, at different pH ranges, and that's not a microbial reaction. That's just basic chemistry. Um, and I mean, even just old school kind of like pre-prohibition, 1980s growers know that pH matters. Hydro growers definitely know it matters, and it's all about nutrient availability. Um, you can just see things go wildly out of control when you get out of general pH of, let's just say, like 5.5 to 8.5. Things can get really bad, and that's just all related to the chemistry of nutrients. It does affect microbial communities, diversity, not abundance, but it changes. Microbes are very sensitive to pH, but that's not why we change pH. And I would say in terms of heavy metals, that's been more of a conversation lately, because if you fail for heavy metals, or there's high arsenic in your soil, then yeah, you may think about changing the pH. But otherwise, I would not be changing the pH just to avoid heavy metal uptake, because that's a very crude science at this point.
Yeah, so I think what she's referencing is probably something that's come from myself or Brandon, and this is the idea that we are running a slightly higher pH as a way of potentially limiting heavy metal uptake, because certain metals are going to be more easily taken up by the plant at lower pH ranges. Like you said, 5.5, around in there, you're going to have much greater heavy metal uptake than you would at 6.5, 7 kind of thing. So I think that's what that reference is. I think something that is interesting, though, off of that question would be this idea that plants can control the pH in the rhizosphere, and they can dictate this by selecting for microorganisms, bacteria or fungi, that are either going to create a more acidic or more alkaline environment in the rhizosphere for that plant. And therefore, we don't need to worry about pH because the plant is controlling that itself.
And my understanding, Tad, is that the primary mechanism of rhizosphere acidification is actually the exudation of organic acids. So it's a direct acidification by the roots, and it's not necessarily a second order acidification by the microbes. Obviously, microbes have that ability too, but I think it's organic acids directly from the roots. But yeah, I mean, that's a significant effect for sure.
That was my understanding too, that it's being pushed by the plant. So the microorganisms are being selected for by creating an environment that they prefer, not by them creating the environment for the roots. It's just flip-flopped is all.
And my understanding too is that the microorganisms, their abundance and their population profile are dictated by, in addition to organic acids that are being spit out, that the roots are putting out a ton of carbohydrates. So essentially they're creating a bunch of carbs from photosynthesis and putting anywhere from 10 to 40% out through their roots. And so it's like a feeding frenzy. And if you really were to get in there and dissect, there's different exudates. And so what exudates are being put out is what's dictating the biology.
Yeah, and the way I've always looked at it is, if the plant can put less energy into trying to maintain an optimal rhizosphere pH, because just the entire soil is already at a pH range that it's going to prefer, then that energy can be put into other plant processes, whether that's growing roots or growing more, above ground biomass, increasing its immune system, whatever. That's sort of the way I've approached it, sort of anecdotally, or looked at it, I guess. I don't know what your thoughts are on that.
Yeah, I was distracted by some of the questions.
It's easy to, that's the thing with these lives. It gets a little bit
Yeah,
tricky.
I'm like, oh, interesting question. Oh, interesting.
Yeah.
Yeah,
Well,
I was just looking.
why don't we jump off to one of those? Go ahead, pick a question.
Yeah, I was just looking at one of these most recent ones, which was like his bed drifted up in pH over multiple runs to 7.5. My opinion is, don't worry about it. Don't try to acidify 7.5. I very rarely am recommending acidification of living soils for a couple reasons. One is the only good way to do it, in my opinion, is elemental sulfur, and you're going to really push. It's a big process, and usually you want to identify the excess that's causing a high pH and usually flush it out if it's sodium or potassium or magnesium for that matter, and that should lower the pH. Also, like I said, I don't think 7.5 is an issue. I personally don't think you would see an improvement in crop health or yield, flower density, anything going from 7.5 to 6.5. So I wouldn't recommend it.
See, I immediately wonder what's in their water, and if they're getting either either a plant important mineral like calcium, or are they getting sodium or chlorides in their water that could be pushing up their pH.
Absolutely, and that goes without saying.
Well.
Is like, I think if you're growing, you should, every single person who's growing should have tested their water at some point or another. Because yeah, I mean, I guess you're getting at, why would the pH be going up in the soil? Yeah, could be water, but it could be mineralization of all kinds of different amendments, So like, just as that compost breaks down, if the molecules making up that compost are full of hydroxides and carbonates, then as the compost breaks down, it's going to push the pH up. Same thing, let's just say you had a granular soft rock phosphate. As those little granular pieces break down and decompose and react, it's going to drive the pH up. I think that, yeah, I'm not going to say that. I was going to say, I see that all the time, pH kind of drifting up. And I think it's just because we're putting in a lot of amendments. And as those the plants are uptaking the nutrients from the amendments, but as they mineralize, they're also releasing bicarbonates, carbonates, oxides, hydroxides. All of those things are putting upward pressure on the pH over time.
Yeah, I take a slightly different approach, but very close, in the sense that I might be willing to apply a little bit of agricultural sulfur to start lowering the pH. Again, depending, I would want to see a soil test to see, first of all, what cations are pushing up the pH, or I'd want to talk to the grower and say, hey, did you just add a bunch of compost or biochar, or maybe we need to back off the amendments, or is it things like you said, like sodium pushing it up, or something out of balance? So it's a complicated question. If everything looked good and it was just your pH was slowly rising due to your water or something, or over application, and it's not a flushing sort of leaching situation, I don't have a problem using a little bit of egg sulfur. I've seen mixed results, and I'm curious your thought on this, about adding more peat moss as a way of lowering the pH, because the research paper I saw in it showed it was ineffective, but I'm not convinced that is the case. Like, could we just make more soil out of that?
Yeah, I mean, you could essentially dilute your existing soil with a new base mix that's acidic. That would totally work. The acidity of peat is not necessarily super strong, so yeah, I don't think you're going to see your soil drop, from 7.5 to 6.5. But it definitely puts downward pressure. So it would help. It would definitely help. But I would probably try to identify the source of the high pH, whether it's water, compost, et cetera, and address that in excess. But again, I don't think I would take action until you're like pushing 8. That's just me.
Yeah, no, I think that's great. Well, why don't we do one more question, because I know you and I talked about keeping these a little bit shorter, but maybe trying to have a consistency of frequency with them, which I think would be really fun. So do you want to pick one more question out of the chats relating to pH that we can chat about?
Yeah. Let me just look through them. Rhizophagy. That's a whole other topic, Craig.
It is. It is.
um,
Yeah.
and I don't know how much that's gonna affect. I think that's a separate conversation on pH. Unless I'm missing something, I don't think that relates to pH.
No, I think that's more about nutrient
Yeah,
uptake.
that's nutrient uptake, and yeah, I get so
We could
pulled
talk
into these
about
topics.
water in relation to pH really quickly and how we can best manage water in
Yeah,
your
let's do
environment.
that because there's a topic that's fascinating to me that that okay. So yeah, we'll get so in general, I think you should only acidify water if you get a water test and there's high alkalinity above 120, but maybe even higher, maybe 160 ppm of alkalinity. The reason for that is you can have a high pH water that's not going to affect your soil pH because it just doesn't have a lot of molecules that are alkaline in it. So your soil will buffer it very easily. So you have to see that alkalinity number. We've talked about that a lot. And only then would I consider it. The other thing I tell growers is get a paste test from Logan Labs and submit your irrigation water. And the combo of the irrigation water plus your living soil, that's the soil solution. That's what the plant roots actually see. So if that is high, if the pH there is high, or you don't want your high alkalinity water putting upward pressure on your soil over time, that's when I would acidify. And I think it's a totally fine practice. I always use citric acid. I'm organic. It's really the only option organically. Um, and
So
yeah, go
if you
ahead.
don't want to use, well, citric acid is a weak buffer. So if you're putting it into a reservoir right there, you're not really going to do anything. It's going to go creep right back up on you. So I think that's something to point out.
So I've noticed it creeps up, and this is where it gets interesting because the creep up to me is if you were to leave it because I acidify like big spray tanks all the time, and I barely use much citric acid. It's very effective and doesn't float up for unless I leave it overnight. Have you seen it float up quickly?
Well, not exactly. I wouldn't say quickly, but I think a lot of people with their aerating the water too, that speeds things up as
Mm-hmm.
well. But compared to phosphoric or sulfuric, I think it's not going to move the needle as quickly, um, and it's more expensive, and it can contain heavy metals. Those are my only concerns with it. Overall, I think it's a
Yeah,
good
I mean
option,
your
but
first 2 points are 100% valid. Problem with phosphoric is it's not organic, and you can really flood. You have to be careful with how much you use because you can flood the soil solution with soluble phosphorus, which can have negative consequences. You also just environmentally got to be careful because you can be like, just yeah, no doubt it's more effective. Same with sulfuric. My issue with sulfuric is it's like kind of nasty to work with. There's things called sulfur burners, but that's for like big, let's just say 10+ acres.
mhm.
It costs like $20,000. So yeah, I mean those are definitely better products to acidify water, but
Well,
organically you've got
if
organic
you're only
acids.
using if you're only using a little bit of citric acid, does that mean your water's relatively low ppm water? It sounds like not a lot of
Yes,
alkalinity in it. Yeah.
exactly. I think that's the perfect point to drive home the alkalinity thing. I don't have a lot of alkalinity, so I don't need a lot of acid to bring down the pH. Um, so
So this is a little bit of an aside, but I think it's important. So we work with a lot of different commercial growers in various parts of the country with various quality of water, and and with this additional heavy metal testing, I think something to point out is that even if your water tests clean, it may be you may want to consider an RO or a heavy filtration system because you might still be getting low levels of arsenic that could be um, contributing to a heavy metal fail in your grow. So let's say you have water that's acceptable for drinking based on EPA standards. Um, that water is allowed to have a tiny amount of arsenic in it because, or it maybe even be non-detectable, but let's just say there's a tiny amount in there and people say their water's clean. um, Even with that tiny amount, because we're putting hundreds if not thousands of gallons into a facility or into a room, that arsenic is building up over time. So that's another reason to filter your water. I think a more interesting question is if we do go with filtering our water and end up with, let's say, an RO system, um, what do you use then to buffer that water most effectively? Do you have anything that you would recommend in terms of products? Because it's going to
Yeah.
be
Okay.
low ppm.
So you're saying like the best way to bring the pH down is to just filter it, for sure. I mean, that's no doubt the best way. Ignoring the cost and the other issues with RO, but yeah, that's a great way. It's just like
RO's
clean it
terrible.
up.
Like I'm
Yeah,
not
yeah,
saying
clean it
it's
up.
right, but there's reasons.
No, sometimes
why
sometimes it's right. I think I recommend RO filtration more often than I recommend acidification without RO filtration, because usually there's something in the water. Usually it's not like half the time when you have a high alkalinity water, it's coming with all kinds of stuff: sodium, chloride, sulfate, bicarbonate. So it's a lot of times like water has sodium bicarbonate. Well, you can get rid of the bicarbonate with acid, but not the sodium. So RO is a totally necessary option for a lot of growers. I recommend just a gram per gallon of water of gypsum.
Great. Yeah.
It's inexpensive. It puts in, I think, beneficial ions that are hard to overdo. I mean, usually people say, well, I'm going to like remineralize it with trace minerals like sea crop, but you need calcium and sulfur in large quantities, specifically calcium. You don't necessarily want vanadium, and you don't want seawater in high concentration. So yeah, I'm more of a fan of remineralizing with just gypsum. It's also easy, it's inexpensive. You're amending with it anyway.
Yeah, this is a pretty common practice to buffer your water when using RO. Do you want to just touch on that, and then we'll call it a day, and maybe some of these people can comment on the live video. How about this? If you have a question that didn't get answered in the chat, because I see there's ones in here, what we'll have you do is follow Bryant's new YouTube. He'll post this live video. You can comment underneath it, and then we'll address the question on his YouTube. So hopefully that'll get people
cool
to start using.
Yeah, thanks, Zach.
I'm trying to think of a way.
I appreciate that.
Yeah. But why don't you talk about really quickly about why we buffer water or agriculturally?
Yeah. And this, I mean, so it's definitely more horticulture, small scale, where you're even using RO, because RO is totally unfeasible once you get to any significant size.
Yeah.
But smaller growers, I mean, for me, it's mostly anecdotal in the sense that people report worse crop performance with RO water. The theory goes that the water, being a polar molecule, wants to pull things into solution. It wants to grab onto things because it has a charge, and so it doesn't play nicely with plant roots. Essentially, like they're kind of fighting. So if you remineralize it, you kind of bind up those charge sites on the water, and it makes it less like a magnet, I guess, is the best analogy. I couldn't really succinctly explain the science behind why RO water is bad. For me, it's more that I've just heard over and over again that people don't like the crop response and they prefer to remineralize it. So that's why I'm like, okay, if that's the case, I would do a gram of gypsum. But I'm sure there's lots of there's more experienced people with this and also other ideas. So I'd be curious to hear your thoughts or other people.
Well, for me, it's something that I've always done. You hear RO water described as hungry water. Like you said, it wants to bond with something. It can strip minerals out of metals and things that it comes in contact with on its way to your soil. So that can be an issue. And that's one reason to buffer it right there. But in addition, like you said, crop response, Kurt Becker with DRAM, he's one of the leading water experts that I know of through Suzanne Wainwright Evans. And I did a podcast with him. And that's something that they always do in the horticultural systems that they set up is you if they have to move to an RO system, they always want to buffer that water again by adding some level of fertility. And typically that's done with the irrigation water, unless the irrigation water is just so horrible, or in this case with heavy metals, it may not be an optimal thing for us to use. But those are my reasons for why I think it's important to buffer your water. Now, that's not to say if you don't, you just apply straight RO water, your plants are going to crash or anything like that. I'm not suggesting that. But just like with pH, as we're looking for ways to reduce plant stress, I think this is something that we can, it's another variable that we can look at as a way of optimizing plant health. So
yeah, cool. And by the way, I never got to the interesting point that I think about a lot with citric acid, which is that when you add citric acid, the pH will drop because it generates citrate ions in the process. But then those are absorbed by microbes and plants, and the pH increases again. So I guess the point I wanted to make earlier is, if you're acidifying your water with organic acids, it's not necessarily going to drop your soil pH over time. So there's a little bit of a misconception that I had for probably 5 to 10 years, which is like, oh, you just acidify your water with citric acid, and over time that's going to push your soil pH down. And it just doesn't work like that, because those organic, it's called the conjugate base of is consumed by microbes. So anyway, I just wanted to make that point. Also, someone just mentioned vinegar. That's totally a great, well, that is an organic way to lower water pH. It's just super expensive.
Yeah, I've never used vinegar, so I couldn't really speak to
The only time I ever use vinegar is in like a vinegar extraction, like a Jadam extraction, oyster shell vinegar, for example. And yeah, you dump that in a foliar spray, it'll drop the pH, but it'll have the same float. And probably the reason that the aeration increases the rate of upward float is probably just because it's like a tea. It's like there's more microbial activity that's consuming the conjugate base of the organic acid. So,
and you mentioned this before. I think it's an important point to drive home, that microbes are very sensitive to pH fluctuations or pH in the soil. And so that by keeping your soil within a good pH range, we're essentially doing soil food web type things by making it easier for the microbes to grow and cycle nutrients.
So I read a microbial book that essentially, if I remember correctly, besides oxygen, pH is the biggest driver in microbial populations. So
water
you can,
or moisture.
Yeah, moisture. I think moisture is. I'm just saying when it comes to different soil conditions. So assuming soil is getting water dry. And what's funny about soil is you can't actually dry out a soil. I didn't know like this. And now we're talking real topsoil. You can dry out a living soil peat-based media to the point of hydrophobia that you can never really get back. But in a topsoil, it's like really hard to dry it out. So there's these microfilms of water where these microbes can survive, like in really bone dry soil, where a plant would be desiccated. Microbes are still living in these microfilms. So when it comes to microbial populations, according to the textbook, it's mostly driven by pH. That's like the biggest variable. So
that is cool.
Which is, I use inoculants. Okay, but every time I use one, I'm like, I wonder if this is doing anything, because the populations are totally dictated by the conditions, the environmental conditions of my soil. So, my soil outside is 8.2, which, it's that asymptotic limit of lime, because my parent material is lime. So my last soil test, sure enough, 8.2. And I'm like, these microbes I'm injecting, I wonder if they were bred in an 8.2 environment. Probably not.
Yeah.
So,
that's another conversation we should get into, but for the sake of you and I could go on and on, but
let's jump off. Thank you for everyone for joining. Join our YouTube channels for more of these.
Yeah. So check out our YouTube. I just want to summarize really quickly. So pH matters. If we can get it into optimal ranges, and again, it's a wide range, but if we can get into that range, you're going to have healthier microbes. You're going to have better nutrient uptake. You're going to have a healthier plant that can put its energy into better or other plant functions, and just overall be a better grower.
Yeah, great.
All right. Thanks, Bryant. I really
All
appreciate
right.
you doing this. Talk soon.
Adios.